Alors maintenant, on va faire un exercice pratique de Smart City, puisque Carlo Ratti, en fait, ce soir, il n'est pas vraiment exactement avec nous, il est à Boston. Il a enregistré sa présentation, et nous l'avons reçue ce matin à 3 h du matin. Donc vous allez avoir Carlo Ratti en personne qui va nous passer sa keynote de 15 minutes. Donc je nous souhaite une très bonne soirée, et donc Carlo Ratti sur la vidéo.
Good afternoon, everybody. The initial plan was for me to connect today via video conference, but then the organizers got a little bit concerned about the quality of the connection, so we decided to do this as a video. So let's get the slides running. So what I wanted to share today is some ideas about mobility in this new space of smart or sensible cities. But first of all, let me share with you something about cities and the importance of cities today. Just 4 numbers, 2, 50, 75, and 80. Cities are only 2% of the crust of the planet, or the surface of the Earth, but they're 50%, actually a bit over 50% of the population. They're 75% of energy consumption and 80% of CO2 emissions. So if we can do something to make our cities more sustainable, the impact at the global scale can actually be quite significant. And, well, how to look at this? What could we do in cities? Well, many opportunities are opening up today because of the convergence of the digital and physical layers. If you want, you could say that the internet is becoming Internet of Things, is entering the space of the city, the space we live in, and hence it's changing the way we can understand cities, we can design them, we can transform them, we can inhabit them. It's about bits and atoms converging with us in the middle, which is the basis of what many people call smart or sensible cities. And what I'll show you today is some projects done primarily at our lab at MIT, the Sensible City Lab. We're based in Boston, but also with a satellite lab in Singapore, and also through our design office, Carlo Ratti Associati, and some of the startups that have come out of both. So today, for instance, we can look at a city like this. That's a visualization that was done by Pedro Cruz from our lab at MIT. It was shown at MoMA, the Museum of Modern Art in New York, but it shows you like a city, like a living organism in a way we couldn't understand it a few years ago, but we can today. In this case, for instance, this visualization was actually done using billions and billions of data points collected from the taxi network of Lisbon. And if you take the same data in another city, that's the same data, taxi data in New York, you can find something interesting. Here you see every pickup and drop-off. What you see here is JFK Airport in New York. If you zoom out, you see here we had JFK down here. We have Manhattan and all of the boroughs. And then, mathematically, we can ask ourselves, well, how many of those trips could be shared? If you want to answer this question, you need to phrase it better. And one way to do it is to say, imagine you want to take everybody to destination when they need to be there, give or take a small delta, a small delay, 1, 2, or 3 minutes. Then if people are ready to share mobility, what would be the minimum number of taxis you would need in Manhattan? And potentially we could share a lot of trips. As you see here, between those 2 points or any 2 points in Manhattan, you got hundreds of thousands of trips connecting them in the course of the year. So in order to answer this question about how many trips could be shared, we need to develop new mathematics. If you take traditional tools, they usually fail when you got such large amounts of big data. So in this case, we used network science in order to answer this question. We developed this concept of shareability networks. You see them here. To the left, you see the shareability network. They tell you how many trips could be shared. To the left and to the right, you got a slightly difference in the delta, in the delay you tolerate, and it shows you to the right the network densifies because you can tolerate a slightly longer delay. Well, you run the analysis across all the taxis in New York, and what we find is quite interesting, that in New York, if people were ready to share mobility, we could actually cut down 40% of the existing taxi fleet and still be able to take everybody to destination when they need to be there, give or take a very small
tolerable delay. Two interesting things happened. So this piece of work we started before Uber Pool, and then when it was published, it came to the attention of Uber. Since then, we started a collaboration with Uber, and as you might know, Uber Pool really does it. Allows people to share mobility, two people going more or less in the same direction to share a car. The other thing that's quite interesting is that when the project was made public and the papers were published, the New York Times did an article, did a review, writing about the results and just saying that, this is interesting mathematics, it's interesting research, but, most New Yorkers would not want to share anything else with any other New Yorker, let alone mobility. Well, it turns out that that is not the case, that now they've been working with Uber on analyzing a lot of Uber Pool data. Well, Uber Pool has been a huge success all over the world. In San Francisco, over 50% of all trips every day actually happen by Uber Pool. And that's quite interesting because it means two people who don't know each other sharing a ride, which means one less car on the road, which means less congestion, less pollution, less energy consumption, and so on. Now, we said that this applies to New York, but actually turns out it applies to most cities across the planet. And this is a more recent piece of research where we looked at New York, San Francisco, Singapore, Vienna, and other cities, and found this kind of universal shareability laws that show us how mobility could be shared across the planet. Now, if you look at this, that's about sharing the ride, but something else interesting is happening at the vehicle level that could actually help us to share the vehicle, not only the ride sharing, but also vehicle sharing. What is happening is that the vehicle itself is becoming like a computer on wheels. What you see here is the thousands of sensors you got on an average vehicle today. And then, we're starting to add additional sensors to vehicles, such as the two little ears you see there. There are LiDAR scanners, more and more cameras. The bottom line is that the vehicle is able today to get a three-dimensional scan of the city, like you see here. You feed all of that into an artificial intelligence system, and at that point, the vehicle can drive itself. Now, the interesting thing about a self-driving vehicle or an autonomous vehicle is not just the fact that you don't need to keep your hands on the steering wheel. The most interesting thing is that the vehicle can give you a lift in the morning when you go to your office, and then can give a lift to somebody else in your family or to anybody else in the city. So that allows you again to change the mobility system of an entire city and to create a new mode of transportation, which is kind of in between public and private transportation. And this is not something in the distant future. This is actually something that's starting to happen today. It will happen more and more in the next few years with self-driving vehicles entering our cities, our roads. A few years from now, then, when everything will be self-driving, other things might change. For instance, traffic lights. What you see here is a well-known traffic light, and traffic lights appeared on our roads when actually vehicles arrived on our roads. But you got an intelligent system where every car knows where it is and where all the other cars are. Then you don't need to stop anymore at the traffic light. You can keep on going, just avoiding bumping into somebody else. A little bit like this. I would suggest that you don't try it yet. I gave a presentation recently in Naples, and they told me, so what is new here? And I can make these jokes as an Italian person, but that's a former Italian minister who said, in Milan, traffic lights are instructions. In Rome, they are suggestions. In Naples, they are Christmas decorations. So again, a traffic light is an intersection is something that seems quite simple to study, but when you look at all the possible trajectories and all the frequencies of arrival, they can become quite complex. So what you see, for instance, here is a real intersection in Singapore. You see the same number of vehicles to the left and to the right. But to the left, actually, the intersection is managed using the most sophisticated traffic light system we have today. And to the right is managed using a slot-based system similar to the one we saw before and to what you would use in an airport. And look at the difference after a few minutes. To the left and to the right, same number of vehicles as I was saying, but the difference in terms of delay per car and number of cars waiting. Now the interesting thing as well is that usually the intersection is the main bottleneck of a road network. You know, it's where you've got two competing flows fighting for the same real estate. So actually, if you can make the intersection a bit more efficient, the impact can reverberate across the whole system. Just a few thoughts about self-driving cars in particular. And here I want to share with you a project we just started less than a year ago with the city of Amsterdam. We started working with Amsterdam, which is of course an amazing city, a city where in the city center you got a lot of water, very small roads, but a lot of water. And so we started thinking about the canals, and we thought about, well, what about self-driving boats? What could you do with them? And of course, what you could do is use them instead of what is used today for delivering parcels, like in this case, or for moving people around, for sensing the water quality, the air quality, the city in general. But also you could use them as a kind of responsive dynamic architecture. Think about the boats like moving floating pixels that you can assemble in case of a special event, of an emergency. You can create like a temporary bridge or a platform or something else. So it becomes like a living dynamic architecture for the city, which of course is nothing new, is what the city of Venice, for instance, has been doing for a long time with all the gondolas. They come together during the Festa del Redentore and create a temporary bridge. But you know, sometimes technology, the beauty of technology is that it allows us to do what we always wanted to do, what we wanted to do in the past, but to do it in a different way. Actually, there's a beautiful quote by Paul Valéry, who says exactly this about, you know, he would like to use technology to do what he used to do, but in a better way. Well, so what we are doing now is working in Amsterdam in order to develop these kind of self-driving boats. We started by thinking about the platform itself. And if you think about drones, the great success of drones is that you only have 4 propellers, you control them in a very simple way, and you can do a lot of things. So it's very easy to build and easy to control. So we started thinking about, you know, about the boats almost like drones with 4 engines. Very simple to control. We started putting the engines first, you know, perpendicular. You see 4 propellers here. You see water jets here. And then mounting them on this platform, making it very, very controllable. You see here in the video one of the first tests on the canals in Amsterdam. See how easy to control, and so also it's totally symmetrical. Here are some more images. High resolution. It can also move laterally. We were talking with the city the other day, and we said, you know, well, you know, even if this were not to succeed, we'll open a toy company because everybody seems to have so much fun in playing with these on the water. I want to finish with something else about mobility. Is that, you know, you probably have heard a lot about drones, such as this one. You know, the idea that tomorrow's cities might be filled with such things, and we may move a lot, you know, in the air. Well, to be honest, I don't think this is going to be the solution for urban mobility. And the reason is very simple. It's just physics. So drones are very good. Quadcopters like this one are very good if you move a very lightweight things. But if you need to move a lot of weight, then they use a lot of energy just to keep the weight in the middle of the city. And then you generate a lot of noise and you move a lot of air. So it's just because of physics, it creates a lot of disturbance. And That's the reason why, if you think about Manhattan, if you think about some of the helipads in lower Manhattan, there's only a very small number of flights taking off every hour. It's dozens of flights, not that much. And still everybody around the helipad, everybody complains today. So if you had to think about solving the mobility solution or addressing some of the mobility issues in Manhattan, then you would need to have not tens of flights every hour, you would need tens of thousands, or even more, hundreds of thousands of flights every hour, which would make the city totally unlivable. So I don't think that this would be the solution for urban transportation, might be the solution for rural transportation, especially in some parts of the world where there is not much infrastructure, might be a solution for very lightweight things, but not really for moving people around our cities. Maybe it's an interesting solution also for fun projects such as this one we're working on right now, which is about drones for doing graffiti, or might be a solution also for something else. In the next project I'll show you, we've been using drones on the MIT campus. And the MIT campus is very difficult to navigate. Many buildings with different numbers. A lot of people get lost, especially Harvard students. So we developed this project to rescue them.
Welcome to MIT. Where would you like to go? Follow me, please. And Artificial Intelligence Lab is the largest research lab at MIT.
To your right, the Media Lab. To your left, the Data Center.
Follow me, please. Approaching your destination.
You have arrived. Welcome to Sensible City Lab.